This is a continuation of lesson 1-3 about segment measurement. So talk about the segment addition postulate. Suppose that you have a segment that is segment LP with point Q on it. The segment addition postulate equation. This is one way to abbreviate segment addition postulate. The segment addition postulate equation would be LQ plus QP is equal to LP. Now remember that there's going to be no segment mark over top of this because we're talking about lengths. Even though it's called segment addition, we're not really adding the segments, we're really adding the lengths of segments. So no segment marks on top. No, so that's an equation, it's got an equal sign, so there shouldn't be any bars over the top. The order doesn't matter, so if you said QL here instead of LQ, that'd be fine. They're segments, so the order doesn't matter. And then you could have this, big segment first equal to the sum. There's nothing special about putting the plus on the left side of the equation. Just make sure you're saying the short plus the short equals the whole entire long segment. It's always the two smaller ones add up to the big one. Okay, so an example. In the diagram, JL is equal to 120. So they're telling you the length of this segment is 120 units. Okay, so first of all, we're going to make a segment addition postulate equation, and it would be JK, which is this part, plus KL, which is this part, is equal to the whole segment, which is JL. Okay, now the problem says, what are JK and KL? So we're going to find the value of x, the value of x that are in the expressions there, and then go from there. All right, so JK is 4x plus 6, and then KL is 7x plus 15. And they told you the whole entire length was 120. Now notice that you wouldn't necessarily have to have the two expressions on the left side. Suppose I had given you that was a number. It's possible to have those two be expressions and then this one be a number instead. It just depends on what's given in the diagram. It's always two small ones add up to the big one. Okay, so we have 11x plus 21 is equal to 120, which means 11x is equal to 99 and x equals 9. Now, have we answered the question? Well, the question said, what are JK and KL? Right, so we haven't answered the question because we found the value of x. So since JK was 4x plus 6, we're going to plug in our 9 there. Move this down a teeny bit in the way. Okay, and that'll be 42. And then KL is 7 times 9 plus 6. That's 63 plus, we got 69. Oh, sorry, 60. Oh, whoops, sorry about that. 7 times 9 plus 15. Okay, 63 plus 15 would be 78. And then how will we know, which is kind of how I just caught the mistake, how do you know if those numbers make sense? Well, just a quick check. When you add those two together, what do you get? It's 120, right? That's what it was supposed to be. So the other thing you could do is when you find this one's 42, you could subtract from 120 and find that one, and then double check by plugging it back in and making sure that it really does give you 78. All right, and then the last idea in this lesson, midpoint. Midpoint and segment bisector. Okay, the midpoint of a segment, I'm sure you've heard this term before. The midpoint of a segment is a point that divides the segment into two congruent segments. Midpoint, pretty easy to understand. All right, so in this picture, they're telling you B is the midpoint of the segment. How do we know? they put the little hash marks here to show you that B is the midpoint. Okay, so here's a picture. Let's say I draw you a segment and I say, okay, here's segment RS. Okay, is M the midpoint of that segment? Well, maybe. We can't really tell for sure. Why not? Well, because it's not marked. So be careful about assuming things. Just because it looks like it's the point exactly halfway between the two endpoints doesn't mean it is unless it shows you that, or it tells you that the midpoint of segment RS is M. Do not assume things. So be careful about assuming segments or angles are congruent. Be careful about assuming right angles. Be careful about assuming perpendicular. There's a lot of things you have to be careful about in geometry that you may in the past have kind of assumed. Okay, and then the last term here is segment bisector. A segment bisector can be a point, line, ray, segment, anything that is cutting a segment in half at its midpoint. Okay, a bisector is something that cuts a segment in half, two congruent parts, and it's going to go through its midpoint. Okay, so in this picture you can tell that L is a segment bisector of segment AC because it's going through the midpoint of the segment. So it's creating two congruent segments on the other side. We just cut the big segment into two small ones. Okay, here's our last example. Now, the problem said Q is the midpoint. Q is the midpoint of segment PR. Now, again, we wouldn't want to assume that. It kind of looks like it is, but unless it tells you either on the diagram or in words, you should not assume that a point is a midpoint of a segment. Okay, now, what about using the segment addition postulate? Okay, so if you try to do 6x minus 7 plus 5x plus 1, what are you going to make that equal to? Well, some people tell me, okay, so let's make this 11x minus 6. Don't bother writing this down, by the way. On the left side, you get 11x minus 6. On the right side, you get 11x minus 6. And, well, that wasn't very helpful because the variables just drop out. You get 0 equals 0. It's a true equation. It doesn't really help you. So why is the segment addition postulate not helpful here? Well, it's because we don't know the length of all three of the segments. We have to have an expression or a number for all three parts. We don't know the lengths of all three segments. So we have to be able to do the two small ones add up to the big one. So if not, then we're kind of stuck. But fortunately on this problem, we know that we have a midpoint of segment PR. So that means that these are actually the same. So we can say 6x minus 7 is equal to 5x plus 1. Now again, I'm not assuming that they're equal. We know that they're equal because it told you it was a midpoint of the segment. So quick little solving here, x equals 8. Now, again, have we answered the question? Well, it asked you for these segment lengths, so let's plug it back in. So 6 times 8 for PQ, 6 times 8 minus 7. 48 minus 7 is 41. Do you know how long QR is supposed to be? Well, it should be 41, right? 5x plus 1, we'll verify that. 5 times 8 plus 1, okay, good, it's 41 also. We knew that Q was the midpoint, so they better come out to be the same. So how long is PR? Well, yeah, sure, you could add this together and call that 11x minus 6, but it's pretty easy to just say, add those together. It should come out to be 82. Okay, this is the end of lesson 1-3.